Good afternoon, good evening, good morning, everyone. We have a very international crowd today, so I don't know where you're joining from, but thank you very much for joining it all for this first event in a series of webinars we launched in order to showcase the topics and the speakers for Future Law 2024. A couple of words about Future Law. It's a legal innovation conference which is taking place in May 2024 for the second time already, and is co-organized by Alleged, the Tallinn University of Technology, and ELTA. And I will get back at the end of the webinar. I will give you a special promotional code for a discount. So stay with us. It's another incentive to stay with us until the end. But I think the topic today speaks for itself, and it will keep you until the end of the webinar. Today, I have the great pleasure of talking with Uwais Iqbal, the founder and CEO of Simplexico, about what else? Generative AI. Uwais, welcome, and thank you so much for educating us today.
Hi, Holger. Thanks for having me. It's a real pleasure to be here.
Great. So if you look at the legal space, there's both a lot of exuberance and anxiety in the market about generative AI. Everybody has an opinion. Emotions are sometimes spoiling over, which is good. We should be emotional about new technology. We need these discussions. But among all the noise about AI, it is sometimes hard to hear the signal. And I have the feeling that a lot of people, lawyers included, do see generative AI as the shiny object that some aliens left on our porch and that nobody really knows how to use. So a lot of us are toying with it and sometimes deliver some interesting replies or funny pictures, but it would help most of us a lot if someone could explain how the shiny object really works. So, well, one of those AI explainers is Uwais. So let's dive right into the magic of generative AI. Uwais, let's start with your credentials. How got your journey into AI started? How did you end up in the legal AI space, and what are you doing at Simplexico?
Sure. I think generative AI is really interesting, but I guess we can get into that later in the conversation. So my academic background is actually in theoretical physics, and then I moved over into technology, and the first job I landed happened to be what was then a legal tech company, Eigen Technologies. They're a competitor of Kira. We were doing information extraction from legal documents, financial contracts. So I joined the team when they were still quite young, and I got thrown into the world of machine learning and AI on the job effectively at a startup, a high growth startup, which was quite interesting. So I ended up learning a lot of the skills of what it meant to do AI and machine learning in industry from a standpoint of not just research, but actually what it means to build a scalable AI system, a scalable machine learning system where you can scale to processing up to millions of contracts to do information extraction in a reasonable amount of time. So I spent some time at Eigentech, and then I moved over to Thomson Reuters, where I sat in the innovation lab. And as a data scientist or a machine learning person, there's nothing more you want than volumes and volumes of data. We had access to an immense amount of content at Thomson Reuters, and in the innovation lab, we effectively had free reign to explore how AI could be applied to TR content. So we did some interesting projects looking at deep learning, what it meant to do innovation within law firms, and how to ideate new use cases for projects with AI in the legal space. After TR, I moved to another startup called Thought River. They were looking at doing contract review using artificial intelligence. So if you have a draft of a contract, how can you use AI to compare that against a playbook to detect if there's deviations or if the terms are acceptable based on standards within the organization? And I had been working up to that point for about 5 or 6 years within the legal industry, building these AI systems. And I had a realization that a lot of the systems I had been building, down to the level of the code themselves, were fundamentally the same. It was the same algorithms, the same code I was writing, 3 different companies who were all doing slightly different things. So then the light bulb went off in my mind, thinking, is there a better way, a more conducive way to actually delivering AI as a technology within the legal industry? So then I jumped ship and I started Simplexico. So the company started in August, and the wave of generative AI and ChatGPT kicked off in November. So the timing was really fortunate. We were really lucky. So what we've been doing at Simplexico has been focusing on how we can be a service provider and how we can be a collaborator to law firms and legal teams on their AI journey to help them at the first level understand the technology. So we do a lot of this work around education, demystifying, dehyping, being very pragmatic about the technology. So we have things we do around education. We also do work around helping scope use cases and structure use cases. What is a use case? How do you define a use case? How do you organize use cases? Through to actually building custom AI solutions for legal workflows and legal use cases. So that's where I've ended up, and I think it's been an interesting journey in that, as someone who's a technologist and a practitioner, I've seen myself step into this role of becoming a translator and being able to explain and talk to the technologies in a way where it's based on fact and a desire to educate rather than hype and marketing and noise elsewhere in the industry.
Yeah, that's really interesting. You really did run with the big guys. Well, so there has been a lot of talk about AI and way too much hype. Could you break down and demystify AI and explain generative AI? Is this just hype, or is there something different with generative AI?
I think when working with lawyers, if there's one thing I've learned, it's always good to start by defining your terms. And so when it comes to artificial intelligence, the struggle is that lots of people are using this term in very, very different ways. And we don't really have a shared working definition of what we actually mean by AI. And then what we mean by generative AI, that's the second challenge. So I think it's useful to start from actually defining what we mean by AI and then building on that. I like to use a working definition where we can think of AI as a technique where we want to take something humans can do when it comes to problem solving or decision making and try and mimic that through the use of machines, right? So it's this enterprise of, as humans, very naturally and very uniquely, there's things we can do which involve cognitive skills. I can, for example, lawyers or myself, for example, can you can look at a contract and we can read an employment agreement and we can identify the termination clause, or we can identify a confidentiality clause, for example. That's a skill in and of itself, being able to read a text and identify something like a termination clause. What we want to try and do with AI is see how we can mimic that same skill or expertise through the use of a machine. So now, rather than having to rely on a human to do that task, we can look to try and use a machine in different ways to try and achieve the same objective. So AI at its core is this entire enterprise of trying to mimic what humans can do. When we think about generative AI, I think it's really interesting if we think about humans and daydreaming. So Holger, when you daydream, what do you normally tend to do?
Well, that's a good question. I don't daydream a lot, but oh, what do I do if I daydream? I really don't have an answer for that.
But what ends up happening if someone's daydreaming? They end up seeing pictures in their mind, right?
Yes, yeah.
And those, where do those pictures come from?
Well, from processed information, from data you're juggling in your head.
So from memory, right?
From memory, yes, exactly.
So as humans, when we daydream, what we tend to do is we have images or experiences in our memory, which we tend to recall. And we take fragments of these memories and compose them in different ways to come up with new images and come up with new experiences, which are far more interesting than what we're potentially focusing on at the moment. So what we're actually doing when we're daydreaming is taking what's in our memory, breaking it down, recomposing it, and creating new structures. So as a human, I can think of an image of a man. I can draw an image of a man from my memory, and then I can draw on another image of a horse from my memory, and then I can compose the two together to come up with the image of a centaur. Right? It's something I can do very naturally as a human being. We have that cognitive skill. So with generative AI, what we have now is machines that are able to mimic this meta skill that humans have. So with generative AI, if you think about the image, generative AI systems that can produce images, if you give a textual prompt to one of these images to create something that looks like a cross between a man and a horse, what effectively these systems are doing is mimicking the same process. It's drawing on its memory or its training data of images which look like a man and images which look like a horse, combining and composing them together into a new image in a way that's cogent and looks like a fully structured image. So in effect, what we're doing with generative AI is mimicking what humans do when effectively we daydream. And the interesting thing for the legal industry, and I think for professional services in general, is the cognitive processes involved in doing highly complex and specialized tasks like legal work and professional services involve elements of daydreaming, involve elements of combining things from memory to come up with new images, new ways of thinking, and new ways of structuring information. And now that's no longer something we can only rely on humans for. Now we can potentially rely on machines to do that. So I think generative AI, although it's been hyped beyond anyone's comfort level, there is actually something significant and lasting in that. If we think about the sphere of things lawyers tend to do on a day-to-day basis, and the things we can now successfully mimic with artificial intelligence to a degree where performance is impressive and sufficient, with generative AI now, that overlap has become much, much more significant. So there are a lot more tasks that lawyers tend to do on a day-to-day basis, which could now potentially be done or leveraged or used or achieved through the use of a generative AI system. So we almost have the two worlds colliding in terms of how lawyers tend to do traditional legal practice, and now where machines can effectively do things and mimic some of those human skills.
So you're talking about mimicking. So to get back to your picture of a centaur, do we have to show it? If you show it to a human or give an idea to a human, draw it. I don't know, 5-year-old child, draw a combination of a human and a horse. They might come up with the right picture, but do we have to show to the AI a picture of a centaur in order to give it a direction where to walk with? Because otherwise you can end up with a combination of human and horse parts which are not very similar to a centaur. So how do we teach a machine, or how does a machine learn, and how does a large language model generate that information out of that data on which it got taught? How does it work? Yeah.
So that's the trouble. So we want to combine an image of a human and a horse. How do we stop the machine from giving a horse head and a human bottom, where we want a human torso and a human bottom?
That's what I was daydreaming about right now.
So I've got Hogger daydreaming, so I must be doing something right. When we talk about large language models, these are generative AI systems where all we're doing is effectively predicting the next word in a sequence of words. So if anyone has tried to learn a new language and they've used one of the language learning apps, one of the exercises which are usually given to language learners is to fill in the gaps or fill in the blanks. So they usually have a sentence in a foreign language with a missing word or a couple of missing words. And at the bottom, there'll be a selection of words where you can choose from those words to fill in the gap. And it's meant to be a good way of increasing proficiency in vocabulary and being able to understand context in a new language. So a language model, the way we train language models effectively draws on this intuition of how humans learn language. So we mimic how humans learn language to be able to teach machines how language works. So we do the same thing. We take lots and lots of examples, on the order of billions of examples, where we have sentences. For example, the president of the United States was Barack. And then we ask the machine, what's the next word? Fill in the blank. And the machine eventually, it might initially get the answer wrong, but then eventually over time through training and through reinforcement, through the adjustment of the weights in the network, in the neural network, then what will happen is the model will effectively move to a space where it can predict the right outcome for the given input. So these systems are made up of neural networks. So we're not just mimicking the output of a cognitive process, we're trying to mimic also how the brain is structured when it comes to information processing. So the intuition is that if we're able to mimic the structure of the brain, then we can better mimic the output of cognitive processes. So if we look inside the brain, we see the brain is made up of lots of neurons connected in different ways. And what we're doing with neural networks is mimicking the structure for information processing. So these models and these deep learning models are effectively constructed of neural networks, where what we're doing is we're giving an input to the model, And depending on the output, we're giving feedback to the model whether or not it predicted the right thing or the wrong thing. So if it predicts the wrong thing, then the model is penalized, and the model has to adjust its ways, adjust the way it processes information until it gets to until it gets to a point where it gives the right output, and that learning is reinforced, and those weights are stabilized so that the model is learning the right thing. So machine learning, in effect, is a way of achieving AI through using lots of data and lots of examples, where what we're doing is, for a given input, we're making sure the model gives the right output. And what we're doing in between is we're tweaking the weights of the network, or we're tweaking the way the information is processed. So on the back end, we have the right output. Now, language models, they take this to a very large scale with billions of parameters and billions of training samples, where effectively what we're able to do is teach these models language through just being able to predict the next word. And in that process, these models, they learn statistical dependencies within language, they learn patterns within language, to an extent where when you're using a tool like ChatGPT, for example, all it's doing is predicting the next word, but it's doing it in a way where it gives rise to all of these more impressive capabilities. So it can summarize, it can draft, it can answer questions, it can create poetry, it can do all of these cool things. But all of that is coming from this one mimicry, or the imitation of a single skill, which is being able to predict the next word based on the previous sentence it's been provided with.
Okay, so but in that regard, the output, can it be better than the input data, or the quality of the input data, or is it always an average of the input or the training data?
So it's always statistically based on the training data it's seen. So if you think about daydreaming and memory, you can't daydream about something you don't have experience of. Okay, so I've never, for example, been to the moon. Actually, that's a bad example. I've never experienced what the center of a black hole is like. So I can't really daydream about that because I don't have any access to memory. So these language models work in a similar way. Their output, or the quality of their output, is predicated on the type of data they have access to in their training. And I think this is really interesting because when we look at ChatGPT, for example, the majority of data it's been exposed to has been data on the internet and public data. And it's not really been exposed to a large degree to very nuanced and sophisticated legal data. So when it comes to trying to do things which require more robust legal output or more robust legal thinking, ChatGPT tends to fall over because that's not within its domain of memory or its expertise.
Okay, we have a question, probably that really steers off a little bit of topic, but yeah, could you explain difference between vector databases and traditional DBs? I guess it's databases.
Databases. Okay, that's a bit off topic, but when we have a database, what we're doing is we're effectively creating a memory store. If you sign up on a supermarket website to order groceries and you make an account, they have a database behind the scenes tracking your name, your personal information, and what you ordered, so that they have a record of that. Those databases are known as relational databases. Vector databases go a step further, where rather than representing the data as is, they transform that data into a numeric representation called vectors. So you can think of it as you can think of vectors like addresses. Okay, if two people have a similar address, if they live on the same street, then they live close together. Okay, if they have two addresses where one person he lives in another country and another person he lives in another country, then those people live very, very far away. So what vector databases allow us to do is not only capture the information, but also allow us to capture how similar or different information is. So, for example, if you ordered groceries from the supermarket online, you might order a carrot. Okay, now the vector representation of carrot should be very close to the vector representation of lettuce, for example, because they're both vegetables and they're both very, very similar. So then the relationship between them should be captured in the database. if you look at something like a carrot and compare that to something like a loaf of bread, for example, the vector representations of those will be very, very different. They'll be very, very far apart because they're not alike. So vector databases allow us not only to just capture the data points itself, but also how close and how far and how similar the data is to one another. So it goes from the data to actually capturing some high level of semantics on the data itself. And then that becomes useful for retrieving things, because if you're looking at carrots, for example, then the supermarket might use a vector database to see what are things similar to carrots that I should show the customer so that he can also buy them. So then when you're looking at carrots, they can look up the vector database and they can see, oh, lettuce and cucumber is very similar to carrots. I should also show these next to the carrots so the customer, he buys similar things. So that's part of retrieving information in a better way, where there's more semantic information encoded into the representations.
Okay, let's get back to some more practical application of legal AI, of generative AI. So let's imagine that we want to train a large language model with our proprietary information or knowledge. How long does it take, and what are the costs involved? So that's probably a lot of people would like to do.
Sure. I think it's always useful to have an analogy so it's easier to understand, because I think some of these things can get quite technical and very complex. So I like to use an analogy where you can think of creating an AI model like a language model in the same way you can think about cooking a dish or cooking a meal, right? So if you cook food, for example, you have the fundament, you have the underlying ingredients, okay, and the better quality ingredients you have, the better quality your dish will be overall. Then you have a recipe, which is a series of steps you follow in order to prepare the food. Then you have the chef, the person who cooks the food, and you have the kitchen, the oven, or the stove where you actually do the cooking. And once the food is prepared, then you serve it on a dish, and you eat the food and you consume the food. So we can take a similar way of thinking, where what we're doing when we're cooking is we're effectively combining lots of different components to create an output which can be consumed. We can take that same way of thinking and apply it to building an AI model. So when we're building or training an AI model, we have the data itself, which is like the ingredients, the core of what we want to do. Then we have the algorithm, which is like the recipe, the series of steps we have to follow in order to create the AI model. Then we have the data scientist or the AI practitioner who has the skills to combine the ingredients in the right way to follow the recipe, so you make sure you have a good dish. And then there's the computing environment or the compute resources where the training is effectively carried out and the cooking is done so you can prepare the AI model. So from this perspective, when it comes to training an artificial intelligence model, when it comes to training a large language model, the thing we need is access to lots and lots of data. But when we say training a language model, I think we have to be more specific. So there's what's known as pre-training, and there's also what's known as fine-tuning, right? So you can think of pre-training as somebody preparing a pizza dough, okay, and packaging the pizza dough up so that if you want to cook a pizza, you don't have to make the dough or the base from scratch. You can use somebody else's pizza dough and then build on top of that. Fine tuning is where you're taking somebody else's pizza dough and you're actually adding your own toppings and ingredients so that you can cook it and you can enjoy it at home. If you're speaking about creating a language model from scratch, pre-training a language model, a large language model, then that's something which requires data on the order of millions of tokens or millions of samples, and that can run it up in terms of costs of training up to millions of dollars to actually run. So the cost is very prohibitive, which means only certain companies with the right funding structures, with the right resources, are able to build pre-trained or foundational large language models. Okay, it's not something everyone could do, not yet at least. The costs are falling. Yeah. What we can also do is we can also take a foundational model somebody else has trained, and this is where the whole open source movement has been moving in that direction, is now people have created these foundational models and open source them in the right way with the right licensing, which means that you can take somebody else's pizza dough, pizza base, and you can now build on top of it, and you can fine tune it, you can customize it, you can bring it home, you can add your own, you can create your own tomato sauce, you can add your own cheese, you can add your own toppings to your liking, and you can cook it in your own oven so you know what's gone into your food. to do fine-tuning is much simpler. And in order to do fine-tuning, you need on the order of hundreds of examples, up to thousands or even hundreds of thousands of examples, depending on the complexity of the type of things you want to teach to the language model. And fine-tuning a language model in terms of running the cooking process and running it on a computer and crunching the numbers to fine-tune it, the cost for that can scale anywhere between tens of dollars up to thousands of dollars, depending on the complexity of the job. So what's happening in the open source community is that the open source community is thinking about how to make these tools more accessible and democratize them so anybody can effectively cook pizza at home. And if you're using a tool like ChatGPT, what you're effectively doing is you're consuming somebody else's AI model. So you're going to a restaurant and consuming food somebody else has made, right? And if you go to a restaurant and you have a nut allergy, for example, if the food's already been prepared, then you can't really do anything about the food. Once the chef has cooked the food and you have a nut allergy, you can only do ad hoc considerations by like removing any nuts you see, but that's very risky because that could cause a problem for you if you have a nut allergy. And then this is where all of the questions come up around data privacy, security, etc. So the open source approach is more conducive if somebody has a nut allergy, for example, because they can take the pizza base somebody else made where they know no nuts were used, and then at home they can trust their own ingredients and trust their own sources and trust their own cooking, so that they know everything that's gone into the model and be more comfortable and have more confidence in the model they've created. So I think there's almost two worlds which are a pairing of AI now in the legal industry and wider. One world of just consuming an AI application like ChatGPT, just using a tool or an application somebody else has built. And then there's the other world of what does it mean to create artificial intelligence models, whether that be pre-training models from scratch yourself or fine-tuning models available, which are available from the open source community.
Okay, but if you're talking about fine-tuning an open source model, does the pre-trained information data somehow impact the outcome if you add on top your own proprietary information, or can you separate that? Because you don't want to have, probably if you give, I don't know, 20,000 contracts you have in your specific industry, you don't want to have 500,000 other contracts somebody put into the system, which provenience you don't know and can't really estimate. Does that impact the outcome or not?
So this raises an important question around data provenance. How do you know what ingredients were used to make the dish, where you can trust those ingredients and you can be sure that those ingredients won't have an impact
Are there any nuts in the bill?
Are there any nuts in the build, right? So this is with open source models. Some models are transparent in terms of what data sets they use to do pre-training. Other models aren't so transparent in terms of the data sets they use to actually create them. So if you look at some of the open source models from Facebook, for example, from Meta, like Llama or Mistral, if you trace the research papers and the publications, they actually have a list of data sets they actually use to train those models. So you can have a look and see for yourself what data actually went into training these models. But then when it comes to fine tuning those models, if the chef is skilled and experienced enough, then he can make sure that the things which the model is learning in fine tuning doesn't mean that it forgets everything else which it has already learned from its pre-training. So there are ways to try and make sure that the model doesn't forget particular things. But I guess the challenge with open source models is primarily that because somebody else has trained them, you don't know exactly what's gone into them, but you still have some level of control in terms of when it comes to fine tuning, you have full visibility and full provenance into what's gone into them.
Okay. Well, so for those lawyers who are looking into technology but haven't made up their mind yet, what would be the areas of legal or administrative work where Gen AI could be applied most effectively? Or today, and maybe an outlook. Of course, we don't know what will be in 6 months with that rapid pace of development, but a little bit how that could be applied today and maybe in the upcoming year.
Yeah. So I like it. I like to take it back to this idea of AI being mimicry. What are the particular things lawyers do on a day-to-day basis which can now be mimicked through the use of AI, not just generative AI, but AI more generally? So at Simplexico, we've been doing a lot of this thinking, and we've collated lots of our conversations we've been having with customers, and we've boiled them down to 7 main tasks, which we call legal AI actions. So those tasks which lawyers do on a day-to-day basis, which we can now think about using AI systems or machines for. So it includes things like extracting information, labeling information, organizing information, comparing information, finding information, and then the 2 generative AI ones are drafting and summarizing information, right? So if you think about a legal services workflow, for example, there are elements of that workflow which involve lawyers having to do those actions. It might involve a lawyer having to read a contract and extract key pieces of information, or extract key clauses and key provisions so that they can do some higher level of reasoning and compare against a playbook or something like that, for example. So with these core actions, what we can now think about doing is migrating some of that work from human labor to machine labor. So where previously humans were the bottleneck, with humans with specialized skills to be able to do these legal actions were the bottleneck, now we can try and remove that bottleneck by thinking about how we can use machines. And the way we use machines can scale across a spectrum from complete automation, where there's no human involved, to augmentation and acceleration, where the machine is working in collaboration with the human, to a few other different combinations. So I think when it comes to looking at the law firm in particular, we've outlined 3 main areas for the application of artificial intelligence. Within a law firm, there is the business of law, and this has to do with things every business has to do: marketing, HR, finance, etc. AI can be used in all of those spheres of a business, and that's nothing particularly special for legal. That's just something which is going to happen to every single business. Then there's legal operations, or the management of legal work, so legal project management. So this is thinking about when it comes to things like billing, matter management, resource planning, etc. Law firms typically have access to a lot of that information and that data within their systems. So can that data be mined and used and be used to train AI systems to do different things, like predicting resources, or predicting billing, or predicting cost for customers on a new matter which comes in, which lawyers have previously worked on in the past. So there are a whole spectrum of use cases there. And I think the most interesting area where AI could be applied in the law firm, which generative AI has now opened up, is this idea of legal practice, which previously wasn't as accessible. How can artificial intelligence be used in the practice of law, where on the day-to-day tasks a lawyer tends to do, rather than having to only rely on humans? Is there a world we can step into where lawyers and machines are working in collaboration within legal services, within the delivery of legal services? So the idea is, how do you take an existing workflow that focuses on delivering legal services, identify areas where lawyers are doing those actions we mentioned, and think about how machines can now potentially be used to do some of those actions to create either an optimized and more efficient legal services workflow, or a more robust and a more predictable, or outcomes which have higher quality in the delivery of legal services. So I think what we'll see over the coming years is, as people start to play with these tools and realize, oh, I do that on a day-to-day basis, but now ChatGPT can do something similar, or I can leverage a machine to do that. So then the thinking will become, how do we integrate and how do we embed AI systems into the delivery of legal services?
Okay, and how about the reasoning part or prediction part? So you see, even before Gen AI, you had some kind of predicting the outcome of court cases. If you look at China, they have a system where an AI basically um, serves the decision to the judges, and the judges have two ways. They either can accept it, and that will be the decision, or if they don't accept it, they have to motivate their own decision. So it's going in a direction where the AI will take over some human reasoning, and to what extent that is already possible.
I think this is the difficulty, in that it it ultimately depends on the type of legal work and the risk associated with it. And risk, I mean, in the sense that who is responsible if something goes wrong, and how responsible is that person if something goes wrong.
Yeah.
If something goes wrong, is it really, really bad? Or if something goes wrong, is it not that big of a deal? So I think it depends on ultimately on the risk. And in scenarios where it's low risk and there is high volume, there it makes sense to try and think about how the human can completely be removed and you can have complete automation, right? So you have a world where the machine does everything.
Yeah.
But I think for scenarios where there is high risk and where there is an engagement with customers or clients or other humans, which involves some aspect of reputation and trust, etc. I think the model we'll see is that AI systems being used in collaboration with humans, where humans still have the ultimate decision-making power or the ultimate choice. So these at the moment with GPT-4, I haven't played around with GPT-4 Turbo yet, but with ChatGPT, you can do elements of reasoning, right? But then for more advanced legal reasoning types of things, these models tend to fall short. So I think as these models improve, there are going to be aspects and elements of legal reasoning these models can do. For
Mhm.
example, taking a series of facts from a case, providing a piece of legislation, and asking the AI system to come up with an interpretation of the facts, or a judgment, or a
Mhm.
decision, or what's this scenario, etc. So I think you're going to be able to do basic things like that. But when it comes to more complex decision making, you're always going to need the context of the client, the context of the matter, the context of the previous relationship of the client and the law firm, and the type of things which have come up in the past, to be able to do those things. And that's not as easy to capture in an AI system as we might think. So I think there's going to be a world where people are going to be using these AI systems, but it's going to be in collaboration with humans.
Okay. So, can you address the risk of using large language models? Everybody is talking about hallucination, but also about bias and data security. Are there ways to mitigate these risks, and how important is explainability in the legal setting?
Right. So when I gave the example about about daydreaming, it's actually because these large language models, they only daydream. Okay, so
Yeah.
as humans, we daydream, but then we also have access to like reality in a deeper philosophical sense, that we know we're daydreaming and then we can turn it off and we can come back to reality. But these generative AI systems, the whole world they live in is just this daydreaming world. So they don't have access to truth. They don't have access to factual information, and they can't do more than just that daydreaming aspect. So hallucination is part and parcel of that daydreaming, in that these models were never designed to do factual prediction. They were never designed to give correct information. They were just designed to predict information. And I think this goes back to the nut analogy, right? So there are things in the legal industry which are super important for AI tools when it comes to being factually accurate and mitigating bias, data security, etc. But I think all of those things can't just be ad hoc considerations after the dish has been prepared, after the meal has been cooked, because it's too late for that conversation. And you can try and put things ad hoc there, but you're always going to end up with problems. I think this is the challenge within the legal industry. I think the bigger thing to think about is, how do you step back into the kitchen and talk to the chefs and tell the chef before he cooks the food, oh yeah, by the way, I have a nut allergy. Oh yeah, by the way, can you consider hallucinations and make sure they're not an issue? Oh yeah, can you consider data security and bias? So that in the process of preparing the AI models and preparing the food, then those risks are mitigated. So I think we have to design our AI models and systems in a way where, from the design of those systems through to the actual implementation and creation of those AI systems, those risks are baked in almost. The mitigation of those risks are baked in. And these are, I think, more important for a specialized industry like legal, because the nature of the work is much more sensitive, and the outputs are much more specialized. So if you take uh, an electrical appliance like a microwave, this is something everybody has in their homes. It's a consumer appliance. Everybody uses, everybody knows how to use. And it's something which does the job of warming food and defrosting food, potentially even grilling food. But if you go and step into a Michelin star restaurant, are they going to be using a bunch of microwaves to cook their food?
Some do.
I would
Some
be
do.
surprised. But they have specialist skills and specially designed tools for their trade as experts to enable them for their work.
Yeah.
And I think part of the problem is that ChatGPT is great, but I think it's the microwave of the AI world, is that it's this mass market consumer appliance where everyone's trying to cook everything in the microwave, not realizing that the microwave can only do certain things really well and it can't do other things really well. And I think it takes taking a step back and looking forward and seeing, okay, this is a generic consumer appliance. Can we imagine a world where we have specialized AI appliances or specialized AI applications and systems for the legal industry, where these considerations go into the design process of those systems? And I think that's a much more exciting world to live in, because then you have to go into the kitchen, you have to build a world where domain experts are able to communicate with chefs and understand requirements and create these systems in a much more robust way. So I think that's some of the work we've been trying to do at Simplexico in terms of thinking about how do we get domain experts involved in the conversation as soon as possible, where in the kitchen they can give their requirements and we can cook things accordingly. And I think those types of systems are designed in a much more robust way, and in a way where we can mitigate for those risks from the start.
Okay, so you're talking about putting a layer of humans on top of the AI.
Yeah,
That will mitigate the risk. But anyway, because what I as a layperson, when we are discussing the application of AI in a legal setting, and you have already practical cases where basically lawyers, if you look at Allen Overy, when they implemented Harvey, they told all their lawyers to check all the results. So that makes a little bit, well, it's still probably
it's still premature.
Well, no, it's still a huge time saver, but if you have to check everything, every output of the AI system, it's a little bit a downer for me.
But I think I think this is why it's important that AI education gets as wide as possible, and we try and demystify things as much as possible. But I think it's a mismatch of expectations. I think people have this expectation that AI systems should be 100% perfect, they should be magical, and they should do everything perfectly just as a human would do. I don't think we're in that world, and I don't think we'll be in that world for a very, very long time. Maybe in 20 years, we'll be at a point where that makes sense. But I think where we are today, these AI systems are very, very nascent. For example, large language models in the form of ChatGPT and GPT-4 have only been around for 12 months, less than 12 months in production where people can actually use them. So the technology is very young. And then if you think about taking an established industry like legal, which has been here for centuries, and there are kind of very concrete ways of doing things, and transforming that in the space of 6 to 12 months, I don't think that will happen overnight. Yeah. So I think people have to be a bit more pragmatic and have lower expectations of what these AI systems can do. I think healthy skepticism is good, but we need to make a distinction between the technology, the application, and the use of that application. Okay, so I gave you the example of the microwave. So the microwave runs on electricity. The microwave is an electrical appliance, and I can use the microwave to do different things. I can use the microwave to warm food. I can use the microwave to defrost food. Now, if a manufacturer creates a bad microwave, he designs it badly, or the microwave doesn't work that well, it doesn't do what I want it to do, then that means that's a bad electrical appliance. It doesn't mean the entire technology of electricity should be dismissed, right? So, and I think this is what's happening with AI, is that people have conflated AI applications or AI systems with the technology itself. So they might use ChatGPT, or they might use Harvey, or I have to check outputs. It's not as good as the lawyer is, and they dismiss the entire technology underneath. So I think it's important that we make a distinction between the technology, generative AI, large language models, applications built on that technology, things like ChatGPT, etc. And then different ways that application can be used. You can use ChatGPT to summarize information, draft information, etc., etc. And the technology is still very young, and the applications using those technologies are still even younger. So I think it's a process of learning for everyone in terms of how to get those applications working in the right way so that we can do the right jobs for people.
I totally agree with it. It's less than a year since ChatGPT arrived, and probably it's just an issue of our very high expectations that this will solve everything. So probably we have to tone it down a bit and wait for another year. I totally agree. We have a couple of questions.
Sure.
I don't know if the people want to switch on their mics and ask. Otherwise, I can just read them. I start with the second one because it's a little bit relates to the risk question. The last one: can't we give machines a few notes of very basic truths to relate to when daydreaming?
Yeah. So this goes into like going back to the kitchen and going under the hood of the engine and tweaking with things. And that's the direction of research at the moment. It's how do you combine the large language models, which are really good at daydreaming, with what you call graphical neural networks or graph structures, which can encode structured factual information. And I think there is active research in that direction, but I think it will be a while before those two worlds come together, where you can actually give truths. But there are ways of doing that. So, for example, we've been exploring this at Simplexico, is when it comes to these models, they basically output. So you give them a sequence of words, a sentence, and they output probabilities or predictions of likelihood of what that next word should be. So if you have some domain knowledge about the legal industry, about how a case citation should look, for example, or what are valid case citations, then you can manipulate the predicted words so that it mirrors something factual. So you can mold the daydreaming to be more factual, if that makes sense. But in order to do that, you have to really get under the hood of a language model and start tweaking with the inner workings of the engines.
Okay. Another question is how to deal with the problem that LLM is creative and often not careful and may generate a legal opinion that is not true instead of not generating anything that is unsure or of questioning it technically.
I think the easy answer to that is you have to sense check them. So you have to review them, right? So you have to see what the LLM does and check the outputs yourself, because as a legal expert, you have the expertise and the skills to be able to tell what's a good opinion and what's a bad opinion. And we're not at that space yet, but when we have some of these specialized AI systems, then you can create feedback loops. And this is what we've been doing, for what we've been exploring for a few projects, is how do you create feedback loops with legal professionals so you can capture whenever the system fails, for example, an LLM fails, we can capture what the lawyer's expertise or the lawyer's expecting as output, and then use that as training data in the next round of fine-tuning to improve how the models work.
Okay. What are your thoughts on the importance of interoperability between AI and traditional platforms such as Zoom, Google, etc.? Right now, we know that Zapier is one of the leading market players for providing this interoperability, from which, at least personally, I have seen some interesting use cases compared to market players who focus on specific legal solutions. Are these interoperability platforms platform providers something that is going to be inevitable going forward?
I'm not sure I understood the question completely, but I think it's talking about getting different systems to talk to each other with AI. I'm not too sure.
That's how I understood it.
Yeah.
Maybe Sandra, you can switch on your mic.
Yeah. So this is basically, I mean, Zapier is this kind of system where you can use ChatGPT, right? All these blocks and everything, and you just start connecting. I don't know, Microsoft Teams. You select your email, and you kind of build this flow of tasks. And this is kind of like a use case, essentially, right? You start automating very directly. So this is what I was thinking of this kind of, is this something that is going to be a big thing going forward in this kind of AI automation scene in general?
I do think so, in that data is stored in different systems. So for example, like your emails are in Outlook, your meetings might be in Zoom, your documents might be in Microsoft Word, etc., etc. So I think for a more integrated solution, there's going to be a need for those systems to be able to talk to each other. But I would assume there's going to be something from the big tech providers or someone like Zapier to be able to do that just for applications. I don't know if there's something similar happening in the legal industry, if someone's thinking about building something to connect point solutions to be able to talk to each other and move data across in a way which uses AI.
Does this answer your question, Sandra?
Yeah, in general, I was just curious whether, this is something that people are also discussing. So.
All right, good. And I have a question about copyright issues of AI training data sets. Can these data sets be copyrighted? Is there any real life case example?
So this is a good question. So when a data set is created, it's usually associated with a licensing, and the particular license permits certain types of use. And depending on how that use is, then I'm not an expert in copyright law. There might be someone on the call who's an expert in copyright law, but depending on what's considered permissible use and impermissible use, then that can have an impact on what's used to create them. So currently OpenAI is being sued by, I think, a good number of people around leveraging or taking data from the internet, which they see as an infringement of copyright and an intellectual property. So some data sets have permissive licensing where you can use them for creating AI models and doing further research with them. Some data sets, for example, are restrictive where you could only use them for academic purposes. Other data sets are permissive and can be used for commercial types of things as well. So a real life case example. So Atticus has the contract understanding Atticus dataset, and if you look at the licensing for that, then that's probably a good example of where you can see where the owners allow you to use that data for certain things and not use it for certain things.
Okay, any more questions?
Yes, please, if I may.
Yes, sure.
Sure.
Hi, I'm Jouko Nuttila. I'm a researcher at the University of Lapland. So I would have thank you for the interesting discussion. I would have one specific question regarding ChatGPT.
Sure.
The first part of the question is that we know that in addition to the pre-training of the model, they have put a lot of human working hours fine-tuning in the model, basically making filters to restrict undesired outputs. And now, like a week ago, they announced this GPT builder, which seems like pretty interesting. You can take your own data in. So I'm asking your opinion that what do you think that making like company specific GPT with this GPT builder with your own fine-tuning data. So do you think that is a problem that they have done a lot of manual work in between if you try to use your own data to kind of like train your own GPT? And what do you think about like amount of data needed to make something useful out of that own dedicated company-based GPT?
Sure. So there's two things I think you need to disambiguate. One is fine-tuning, and the other is what's known as retrieval. Okay, so what they announced with GPTs is that you can build a customized GPT for a particular kind of use case for an assistant, etc. Fine-tuning involves actually updating the model itself so it can do something different and making the model learn something new. What you can also do is give a large language model access to external content and information. so that it can look up that information. It can also answer from that information. That doesn't necessarily involve having to fine tune or customize a large language model under the hood. All it's doing is it's retrieving information from a knowledge base, and then it's incorporating that into the prompts. So I think working with company data or data which is proprietary is very sensitive, and it's always important to check whether or not it's something, whether or not it might cause issues, or there might be some sort of contravention in terms of sharing that data with a third party like OpenAI. And I think this is where the interest is in terms of building open source models and bringing them in-house, so you don't have to send data to a third party. But there are things you can do. So you can, for example, upload your, I don't know, take something like a knowledge base or a knowledge wiki that someone's developed within an organization, connecting that with a large language model so it can retrieve information, and then someone can, rather than having to search through the knowledge portal, they can write a question in natural language just as they would with ChatGPT, and it can go and fetch the right information, and it can create a nice output for that. So I think there's different ways you can work with these systems. Some are more straightforward. So for example, building a retrieval system is a lot simpler. And now you could do that with like a drag and drop interface with the new announcements. And then fine tuning a model is a bit more complicated, where you have to spend some time organizing and structuring your data to actually customize the model and make it learn something new.
Thank you very much. Thanks. Great answer.
Great, everybody. We are running out of time. So thank you very much for the questions, and thank you, Uwais, really, for that. The time flew by. I never have seen anybody explaining in simple and understandable words how a very complex technology works. Fantastic stuff. One last question, because I guess everybody will go out of that webinar with a couple of questions. How can people reach you?
So I'm quite active on LinkedIn. I post regularly about AI in the legal industry. So I'll pop my LinkedIn profile in the chat, and feel free to drop me a message on LinkedIn if you need help with anything. At Simplexico, we're doing a lot of this work around demystifying, educating the legal industry. So if anyone has any questions or they want to chat, feel free to drop me a message and you can stay in touch.
Perfect. Thank you again. Thank you, everyone, for joining us today, and hopefully see you in May 2024. And you can meet Uwais again, because he will be one of the keynote speakers and experts at the conference. So have a nice evening or nice day, everyone. Thank you again. Bye-bye.
Thanks, everyone. Bye.